Welcome to the Explainer. Today, we're stepping straight into the ultimate exam match for Cambridge 9618 students. I want you to completely change how you view this subject. Think of your computer science exam not as a simple memory test, but as a high-stakes, strategic game of chess. To win, especially when you're tackling incredibly complex, multi-layered topics like Ethernet and CSMA/CD, you absolutely cannot just react to the board. You can't just stare at a question and hope the answer magically appears. You need to think 5 moves ahead of the examiner. You need to anticipate their traps. Today, we are going to decode exactly how you can master collision detection and avoidance simply by getting inside the examiner's mindset. We're going to break down the exact strategies that top-tier students use to dominate this paper. Let's dive right in.
First up, we've got to address the elephant in the room. Why is it that so many incredibly smart, well-prepared candidates completely fall apart when faced with multi-step calculations in this specific topic? Well, from analyzing thousands of past papers, it usually comes down to 2 very specific types of students. Let's call them Alex and Sam. On one hand, we have Alex. Alex is the fact dumper. Alex overloads the page with raw computer science facts, meticulously writing down literally everything they know about the topic, but offering zero actual analysis. It's just a wall of text. On the other hand, we have Sam. Sam is the rusher. Sam panics, rushes through the question, and completely misses the command word requirements. Explain gets treated like state, and analyze gets treated like describe. You know what happens? Neither of these approaches works. The examiner isn't looking for a textbook robot who can recite definitions, and they certainly aren't looking for rushed guesses. They are looking for a strategist. They are looking for someone who can deconstruct a problem logically.
Here is our masterclass roadmap for today. 1. Core principles. 2. The method-mark strategy. 3. The procedural framework. 4. Critical evaluation. And 5. Examiner insights.
Okay, let's dive into Section 1, Core Principles, Setting the Board. CSMA/CD, Carrier Sense Multiple Access with Collision Detection. Now, this isn't just a string of fancy networking buzzwords that you can memorize and regurgitate. It is a highly specific protocol that relies entirely on precise definitions and causal relationships. It's a cause and effect engine. Think about it logically. If node A transmits a frame and node B decides to transmit at the exact same time, a collision occurs on the shared medium. That is the cause. So what's the effect? The voltage spikes on the cable. The collision is detected. A jam signal is immediately sent out to warn all the other nodes. And then a random backoff algorithm is triggered so they don't just instantly collide again. The Cambridge syllabus explicitly states that your knowledge, your understanding, and your logical reasoning are the fundamental assessment objectives here. You have to explain the why and the how step by step, not just state the what. You need to show the examiner the exact sequence of events, just like writing a precise algorithm.
I want to share a massive secret with you pulled straight from a principal examiner report. They explicitly state, and I quote, "Candidates referencing cross-topic connections achieve significantly higher marks." What does this actually mean for you? It means top-performing students, the ones securing those A stars, don't view CSMA/CD in a vacuum. They don't treat it as an isolated chapter. Instead, they seamlessly connect it to networking hardware, to binary representations, to data security, and to network topologies. Exhibiting conceptual understanding that you can actively transfer to completely unfamiliar contexts is the ultimate grandmaster move. When you can explain how a collision physically alters the binary voltage representation on a copper cable, you aren't just answering a question, you are proving absolute mastery of the subject.
Moving on to Section 2, the method-mark strategy. This is where we focus on exactly how points are won on the board.
So here is a rule you must engrave in your mind. Method marks equal points for process. When you are dealing with a complex collision calculation, maybe figuring out the propagation delay or the backoff time limits, examiners award marks for showing clear, logical working. They literally give you points for the process, even if your final numerical answer ends up being slightly off because you punched the wrong button on your calculator. You are being graded on your algorithmic thinking. You have to document your mental steps on the page. Now, before we continue on to the exact procedural framework to guarantee these marks, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Trust me, you do not want to miss the strategies we drop every single week.
All right, Section 3, the procedural framework. Let's look at the technical methodology you need to deploy.
Whenever you face complex data interpretation in a CSMA/CD problem, you cannot afford to panic like Sam. You need a rock-solid, standardized sequence, a 5-step framework. Step 1, identify the key elements. Are you looking at cable length, transmission speed, frame size, or back-off times? Extract the variables. Step 2, apply the relevant principles. What formulas or logical rules govern these variables? Step 3, execute with clear working. This is crucial. Write down every single calculation. Do not do the math in your head. Prove to the examiner you know the steps. Step 4, verify the results. Does your answer actually make sense within the bounds of reality? If your calculated propagation delay is longer than the age of the universe, you've made a mistake. And finally, Step 5, present it in the required format, paying close attention to units like milliseconds or microseconds. This 5-step process extracts evidence directly from the data given to you, ensuring you hit every single assessment objective without fail.
And this brilliantly illustrates the difference between an average student and a top-tier candidate. Let's compare a flawed response to a perfect one. On the left, we have Alex's classic generic knowledge dump. It's just a massive paragraph of raw facts with absolutely zero logical flow. It's exhausting to read, and it doesn't actually answer the specific prompt. Conversely, on the right, we have a perfect answer. It uses a structured framework, like PEAL, point, evidence, explanation, link. It shows a step-by-step algorithmic decomposition of the network scenario. The strategist isn't just mindlessly writing. They are actively proving their understanding through rigorous structure, proper data structure selection, and logical linking back to the question. They make it incredibly easy for the examiner to award them maximum marks. Let's move to Section 4, Critical Analysis and Evaluation. This is all about higher-order thinking.
To secure those top-tier grades, you must be able to evaluate alternatives and justify your recommendations. Evaluating algorithm quality in CSMA/CD, for instance, critically analyzing the efficiency of the random backoff algorithm or the truncated binary exponential backoff, requires you to identify several key factors. You need to discuss time complexity, space complexity, edge cases, and their direct measurable effects on overall network performance. It's not enough to say it prevents collisions. You have to explain how efficiently it resolves them under heavy network load. This is the advanced tier of understanding. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Now, when you are asked to evaluate or compare two different network solutions, you must use a structured comparative analysis. This requires you to identify both similarities and differences, and you absolutely must use comparative connectives like whereas, conversely, on the other hand, or similarly. But here's the real kicker, the thing most students forget. Every single claim you make must be fully supported by concrete evidence from the specific data provided in the question. You cannot just vaguely state that solution A is faster. You must prove it. You have to say, solution A is faster because the transmission speed is 100 megabits per second compared to solution B's 10 megabits per second, resulting in a significantly lower latency over the 500-meter cable. Evidence is everything.
Which brings us to Section 5, our final system check, Examiner Insights, the top pitfalls. After analyzing years of principal examiner reports, we have found that there are exactly 3 critical warnings from examiners. 3 major recurring pitfalls that cause otherwise incredibly well-prepared students to lose super easy marks on multi-step calculations. Let's reveal exactly what these traps are so you never fall into them. Mistake number 1. Failing to rigorously check overflow and edge cases in your CSMA/CD logic. Think about it. When collision counters increment after every failed transmission attempt, what happens when they hit their absolute maximum limit, like the 16th attempt? The frame is dropped and an error is reported to the higher network layers. So many students just completely forget to state this edge case, and they lose the final culmination mark. Mistake number 2, ignoring boundary conditions. In the context of Ethernet, this usually means failing to consider the minimum frame size required for collision detection to actually work across a maximum cable length. If the frame is too small, the sender will finish transmitting before the collision signal even has time to travel back along the wire. If you ignore the physical boundaries of the network, the speed of the signal versus the length of the cable, your theoretical math is completely useless to the examiner.
And then we have mistake number 3. This is the absolute biggest examiner alert across all Cambridge computer science papers, providing generic answers. Look at the comparison on screen.
Writing a blanket statement like, collisions are detected on the network, earns you 0 marks. It's too vague. However, writing, in the specified office LAN scenario, when node A's transmission, earns full marks. Do you see the difference? You absolutely must link every single point you make to the specific context of the question. If the exam scenario is about a hospital database, talk about the hospital. If it asks about a specific office LAN setup, your answer must explicitly reference the nodes in that office LAN. Generic, copy-pasted textbook answers are the fastest possible way to lose the game.
So let's bring it all together and summarize your complete Grandmaster blueprint for conquering 9618 Ethernet and CSMA CD. First, decode the command word, deconstruct the question, and extract the specific context. Second, select your analytical framework, making sure to use Peel to structure your paragraphs logically. Third, execute all your math with incredibly clear notation to guarantee you pick up every single method mark. And fourth, always check your boundary conditions and edge cases. Students who implement these exact computer science strategies see an average improvement of 2 grade boundaries. But that only happens if they practice consistently with our weekly videos. Here is your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're currently facing. Our team responds to every single comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.
I'll leave you with this final provocative thought. If the examiner's next move on your paper is a completely unfamiliar network scenario, something entirely out of left field that you have never seen in a textbook, is your analytical strategy robust enough to adapt and conquer? Mastering the deep methodology we covered today ensures that no matter what crazy scenario the examiner plays, you are always 5 moves ahead. Keep practicing, keep analyzing, and I'll see you in the next explainer.